over another example of tabular integration, which is a version of integration by parts. So we went over this on the other video that tabular integration is best used for integrals where you have the antiderivative of a polynomial multiplied by either, it could either be a trig function, a trig, or exponential function. All right, these are the type of problems that you use tabular integration for, and in all cases, you always want to assign u as your polynomial function, and then the u is basically the trig or exponential function. The goal here is by repeatedly differentiating u when you're looking for well, I'm sorry, this is supposed to be dv. When you're repeatedly differentiating u, when you're looking for du and the integration by parts, eventually the polynomial function is eventually going to become 0. And then this one keeps cycling either between sine and cosine, or it just remains an exponential function with some constants that vary. Alright? So these are the kind of problems that you use tabular integration for. So let's take a look at example 2. Hopefully this setup will help us easily identify u and dv. So for example 2, we're going to evaluate the antiderivative of 3x to the third plus 2x uh, cosine x dx. Okay, so this is what we're going to evaluate. So in this problem, what is u? We see that we have a polynomial function and a trig function here, so this is a prime candidate for tabular integration. So what we're going to do first is basically set up our table for u and dv. So let's put it on the center. So under the u column, we're going to keep repeatedly differentiating here. This is the one where we differentiate to find the u. And then under my dv column, I'm going to be integrating to find v. So you integrate here, and then you differentiate there. So as indicated earlier, the polynomial function is always what u is. So we're going to extract this polynomial component, 3x to the third plus 2x as my u, and then the remaining piece, cosine x dx, cosine x will be my dv. Alright, so this side I'll keep differentiating until I end up with a row where the u is basically 0. Okay, so let's start. If I differentiate this, I'll have 9x squared plus 2. And then when I take the integral of cosine x, the integral of cosine x is sine x. Alright, this is not 0 yet, so we keep going. Differentiate this again. We're going to have 18x. And then the derivative of 2 is 0. And then the antiderivative of sine x is simply negative cosine x. Alright, and then keep on going. Let's make this a little bit longer. When you differentiate 18x, you end up with 18. And then the antiderivative of negative cosine x is negative sine x. Keep going until this is 0. So when you differentiate this, this is 0. And then the antiderivative of negative sine x is cosine x. Alright, so there you have it, your tabular integration column. So what we're going to do is we're going to start drawing our diagonals and applying the signs, okay? So what you do is starting from left to right, as indicated before, you just draw diagonals. This goes down to this. First row to second row. First row on the left to second row on the right, and then second row on the left to third row on the right. So just keep that pattern going. This goes down to that, and then this goes down to that. 0 doesn't go to anything because it's going to just make it 0, so it's unnecessary to do that. Alright, so now for the sign considerations, please always start with a plus. You have a plus that will be multiplied with this, and a minus which will be multiplied with that, a plus multiplied with that, and then a minus that will be multiplied with that. Okay, so let's multiply them together and then find out what our result is going to be. So basically We're gonna have, if we put them together, the first one, if I distribute sine x into that, I'm going to have 3 x to the third sine x plus 2x sine x. Alright? And then we go with a cosine. This minus times this minus makes this cosine a positive. So it's simply going to be plus. If I distribute cosine x with 9x squared, it's going to be 9x squared cosine x. And then when I distribute cosine with 2 plus 2 cosine x. Alright? And then the next one is going to be, this is going to be negative sine x, because plus times minus is a minus, times 18 is going to be 18x sine x. So I can put that under here. It's going to be negative 18x sine x for this two product right here, because of this minus makes that a minus times a plus makes that a minus, so minus 18x sine x. And then this one is going to be negative 18 cosine x. So I'm going to place that over here because it's a like term with this, so negative 18 cosine x. Okay, so all I'll just do is just add them downwards, and that will basically give me what my final result is. All right, so if I add it downwards, uh, I'm gonna get the antiderivative that I seek, which is the antiderivative of 3x to the third plus 2x cosine x dx is gonna be, this one just comes down on its own, 3x to the third sine x. And then when I combine these two, it's going to be negative 16x sine x. This one has no common term, so I'll just bring it down, plus 9x squared cosine x. And then the last but not the least term, if I combine these two, I will have negative 16 cosine x. Okay, and all right, and then I'll just have my plus c as my constant, and that's basically that. So plus the constant c, and there goes my result. Okay, so that's how you do tabular integration. All right, thanks so much for paying attention to this presentation. Please feel free to subscribe to my videos for future updates. You can always request videos if you have any particular questions that you want me to make a video on. Just request it. And then if you want to see the collection of other videos, just go to mathgoodserve.com and you have a collection there. All right, so have a wonderful day.